Good morning, students. In the previous lecture, we have studied different types of keys, definition of keys, and their applications with respect to torque. Now, in this session, we are going to study the different failures of key and design procedure of key. Basically, there are two failures of the rectangular sunk key. First is shear failure and second is crushing failure. Now, we will go through the procedure. Suppose T is the torque transmitted by the shaft and F is the tangential force acting at the circumference of the shaft. Suppose D is the diameter of the shaft and this is the circumference, and at this point tangential force acting is F. D is the diameter of shaft. L is the length of key. L is the length of key. W is the width. W is the width. T is the thickness. Tau and sigma ck, they are the permissible shear and crushing stresses. Now we will study the different failures, shear failure and crushing failure. The figure shows, this figure shows the shear failure of the sunk key and this figure shows the crushing failure of the sunk key. Now the shear resisting area, resisting area will be equal to, this is shown by the hatching lines, red hatching lines, and that is equal to W into L, and crushing area will be equal to, shown by the red hatching lines, and that is equal to T by 2 into L. Crushing area is equal to T by 2 into L. Now we will consider the key in shear failure. We will form the strength equation in shear failure and in crushing failure. Now shear stress is equal to tangential force upon shear resisting area. So this will form the strength equation in shear. So shear stress is equal to tau is equal to F upon W into L, where F is the tangential force, and in crushing the strength equation will be equal to crushing stress is equal to tangential force upon crushing area. Now sigma ck is the crushing stress and F is the tangential force upon crushing area is equal to T by 2 into L, where F is the tangential force. So these are two strength equations that we have obtained. Now basically the key is meant to transmit the torque, so we will find out the torque equation. So torque is given by the force into radius. So here we equate the torque is equal to shear force into D by 2. So putting the value of shear force is equal to W into L into tau, that is multiplied by, this is the shear force, and that will be multiplied by the radius, that is D by 2. So this is the torque equation based on the shear failure, and here the torque equation based on the crushing failure. So torque is equal to force into radius by the definition. So here we will put the value of crushing force. So crushing force is equal to sigma ck into T by 2 into L. So this equation torque becomes is equal to sigma ck into T by 2 into L multiplied by the radius, that is D by 2. So these are two equations that we have. Now suppose we want to design a key. The procedure is that by empirical relations, suppose rectangular key is there, by usual proportions we take W is equal to D by 4 and T is equal to D by 6 for the rectangular key, and for square key W is equal to T, that is equal to D by 4. We find out the values of W and T, and after finding the values of W and T we will calculate the value of length of the key by this equation T is equal to W into L into tau multiplied by d by 2, and from this equation t is equal to sigma ck into t by 2 into L multiplied by radius, that is d by 2. Now we will have the two values of L. We will get a value of L from this equation, one value, and another value from this equation, and we will consider whichever is larger. So this is the procedure of design of rectangular Sankey. So we will meet in next session. Thank you very much.